In this video, I want to show you how to solve a real-life problem regarding exponential models, or using an exponential model to help us with this problem. And so we have this problem that says the value of a car, Y, expressed in thousands of dollars, can be approximated by the model Y equals 25 times 0.85 raised to the t power, where t is the number of years since the car was new. All right, so we're going to do each part of this problem, and the steps will break through, or will be brought in for each, with respect to each part of the problem. So it says for part A, tell whether the model represents exponential growth or exponential decay. All right, so this is an exponential function. We just got to figure out which type it is. All right, so it says first to identify the value of the base and then answering the following questions. All right, so let's get the base part first. Remember, the base is the value in the equation that is being raised to a certain power represented by the independent variable. Now, normally we would see the letter x, but in this case we see the letter t. So whatever value is being raised to the t power, in this case, is the base. So that would be 0.85. All right, and so we got to figure out which type of base this is. All right, now it says here for identifying the base and answering the questions, is the base b greater than 1? In this case, it's not. All right, this value is actually less than 1. So this is an answer to step 1b. Is the base between 0 and 1? We say yes. The base value is in between 0 and 1. And so that is an example of an exponential decay model. All right. So we're going to use the exponential decay model for us to make sense of what we're seeing in this equation here. All right. Now it says change b to 1 minus r. So I'm going to write it as like such. So b becomes 1 minus r, and it's equal to 0.85. All right, that comes from the exponential decay model, which we're going to bring up right now. All right, so this is actually in participation of part B, which says identify the annual percent increase or decrease in the value of the car. Now, because it's an exponential decay model, we're actually trying to find the annual percent decrease in the value of the car. All right, so let's do step 2 now. Step 2 says rewrite the exponential model that applies to the problem, growth or decay. Well, in this case, it's decay. So the equation I'm going to use is the following. Y equals a times 1 minus r raised to the t value, okay? And you see that from the top of the page, all right? That's where it's coming from. Step 3 says identify your initial amount, a. Well, the initial amount that we see is whatever value is not being raised to the t power. Well, the only value I see there is this, 25, okay? So that actually is in reference to the initial amount, all right? Now expressed as thousands, like the y value is, whatever the number is there, that actually would represent the value in thousands. Okay, so in this case, since a is 25, the initial value of the car is actually $25,000, only represented by the 25, the number 25 there. All right, so step 4, says to do the following. Set your growth or decay factor equal to the value inside the parentheses and solve for r, which will give you the percent increase or decrease respectively. Now, since we're dealing with an exponential decay model, this is actually our decay factor. All right, so I'm going to rewrite this part down below. And we're going to solve for r. I need to find out what that value of r is, because that's what problem B is trying to get us to figure out. So in order for me to solve for r, I first need to get rid of that 1. Well, the best way to do that is by subtraction. So I'm going to subtract both sides by 1, leaving me with negative r equals whatever 0.85 minus 1 is. Well, that's actually negative 0.15. In order for me to get rid of the negative in front of the r, I'm going to divide both sides by negative 1. That cancels it out here, leaving me with r equals 0.15. Okay. Now, what that means is because this expressed as a decimal is the annual rate of decrease, because it was 1 minus r, okay? This is the annual rate of decrease. So we would write, or the annual percent decrease, annual percent decrease is, now I would prefer to write it as a percentage, not as a decimal. The best way to do that is to take your decimal and you would multiply it times 100. And that'll give you the percent. Now, if I multiply any decimal by 100, it's the same thing as moving the decimal 2 places, and it would be over there. So this would actually be 15%. The annual percent decrease is 15%. Okay, so that's the R value. All right. Now, for problem C, it says estimate when the value of the car will be $8,000. All right, so there's a couple of things that that I need to indicate here. Now, remember, y is expressed in thousands of dollars. Okay, so that does not mean I'm going to replace the value y, right? The value of a car, which is y. I'm not going to put in the number 8,000. I'm actually just going to put in the number 8, because that represents $8,000. And so if we're referring back to the original equation, all right, in order for me to solve for t, there are a couple methods to do so. One is I can plug in values for t, because problem C is asking estimate when the value of the car will be $8,000, right? So how long is it going to take from when you take the car off the lot, right, at the original price of $25,000, will it drop down to become $8,000? That's what we need to figure out. How many years is it going to take for that to happen? All right, remember, t is the number of years since the car was new. Now, I could plug in values for t in order for me to figure out 25 times what value will get me 8. All right. So on the VR notes, I have a table listed out of different values that I plugged in to solve or to figure out when would the y value become 8. Another way of doing it is by doing the following. I'm going to divide both sides by 25. All right. This is actually step 5, by the way, and this part is step 6, is now solving for t. If I divide both sides by 25, well, 8 divided by 25 is actually going to get us 0.32, so I'll move it over here. 0.32 is equal to now just 0.85 raised to the t power. All right. Now, in order for me to still solve for t, in order for me to get t by itself, all right, I'm going to refer to method number 2 in particular. The way this works is whenever you see the exponent be a letter, it's best to get that down from being an exponent to just being another value, either in front or on the side there. The best way to do that is by doing what is called logarithms of both sides. So here's how I'm going to do it. I'm going to put log in front of both the 0.32 and the 0.85 raised to the t value. Okay. Now there is a specific property for logarithms that we would use here. This would be called the power of a property, or power property of logarithms. Okay, so this doesn't change, log 0.32. However, because the property states that if you have a value here raised to whatever the exponent is, I can bring that exponent to the front, and they're actually still equivalent to each other. So this up here is actually equal to that. Now I have the t in front, and there is actually a multiplication going on in between. The best way for me to get the t by itself is by dividing both sides by log of 0.85. Okay. Now, by doing that, that gets rid of the log 0.85 on that side, and then on this side, I can just figure out using a calculator what that will get me. And roughly, that means I'm going to get a value. Specifically, I'll get 7.011 is roughly the value of t. Remember, t is supposed to represent years. So I'm gonna limit it down, or I'm gonna kind of I'll approximate it to just 7. Now remember, t represents the number of years. So roughly, it's going to take 7 years for a new car valued at $25,000 to drop down to just $8,000. Okay, that's method number 2. All right, and it's a shortcut way of trying to figure out the value. And so hopefully that's helpful. We're going to do a couple more problems where we'll involve that again.